1 out of every 3 bites of food you eat relies on a bee. That morning coffee you can't live without. Bees. The apples in your kid's lunchbox, the avocados on your toast. All bees. But here's the scary part. That engine is breaking down. Colony collapse disorder means our bees are dying off, at a terrifying rate. Pesticides, parasites, climate change. Commercial beekeepers are losing 40% of their hives every year. Imagine if 40% of all cars just stopped working. So, what's the backup plan? Engineers are building RoboBees, tiny drones designed to pollinate when real bees can't. Today, we join the mechanical hive. The original RoboBee was born at Harvard's Weiss Institute, about the size of a quarter, lighter than a grain of rice. This tiny marvel was the result of years of research and countless prototypes, all aiming to mimic the agility and efficiency of real insects. Getting something that small to fly meant inventing new tech, piezoelectric actuators, artificial muscles that flap carbon fiber wings 120 times per second. These actuators are so precise and lightweight, they allow RoboBee to move with the same rapid wing beats as a real bee, opening up new possibilities for micro-robotics. It could hover, fly sideways, and navigate obstacles, a breakthrough in micro-robotics. For the first time, engineers had created a robot that could perform complex aerial maneuvers at such a small scale, inspiring visions of swarms of tiny drones working together. But powering it, that's the paradox. Even the tiniest battery is too heavy. The challenge wasn't just about making it fly, but about keeping it airborne without being weighed down by its own power source. Early RoboBees were tethered by wires, great for labs, useless for fields. These delicate tethers supplied power, but limited the robot's range and potential applications outside controlled environments. The team explored everything from laser power to micro-fuel cells, all aiming for autonomy. Each idea brought its own set of hurdles, but the goal remained the same: to free RoboBee from its leash and let it roam independently. A true RoboBee needs to be self-contained, wireless, and scalable. Millions, not just one. Imagine swarms pollinating crops, searching disaster zones, or monitoring the environment, all working together seamlessly. The body was built, but giving it life, real, untethered flight, became the next challenge. Achieving this would mean overcoming the final barrier between concept and reality. Solving power isn't just about practicality, it's about making a mechanical hive possible. Only then could RoboBees truly work together, just like their natural counterparts. The journey from lab demo to real-world pollinator had only just begun. The dream of a robotic swarm, buzzing with potential, was closer than ever, but the next steps would be the hardest yet. So, we have a tiny robot that can fly, but can it do more than just hover in the air? Can it actually help with one of nature's most important jobs, pollination? Real bees use static electricity and fuzzy hairs to collect and transfer pollen, nature's perfect system, honed over millions of years. Their bodies are designed to pick up pollen grains as they brush past flowers, and then deposit them as they move on. Dr. Eijiro Miyako in Japan took a different approach. He created a tiny drone with horse hair, coated in a sticky, non-toxic gel, mimicking the bee's fuzzy body. This gel was specially formulated to pick up pollen without damaging it. He manually flew the drone into lilies, carefully picking up and depositing pollen from flower to flower. Amazingly, it worked. Seeds grew, proving that artificial pollination was possible. But you can't have 1 million people piloting drones by hand in every field. For this technology to scale, automation is the next big hurdle. The drones need to work on their own. Real bees use vision, smell, and memory to find flowers. They can remember which flowers they've visited and even communicate with other bees. RoboBees need sensors and AI to do the same. These robotic pollinators must see flowers, identify pollen, and navigate complex environments, all without human help or guidance. Turning a flying paperclip into a real pollinator means giving it a brain as well as wings. It's about combining delicate mechanics with smart software. The challenge is huge: perception, decision-making, and true autonomy all packed into a tiny flying machine. That's where the robot in RoboBee really matters, because only with advanced robotics can we hope to match the genius of nature's pollinators. One bee can't pollinate a farm. It takes a colony, a swarm. Each individual is small, but together, they become a force of nature, working in perfect harmony to achieve what none could do alone. Swarm intelligence is the key. Not one central brain, but thousands of simple robots, following basic rules, creating complex group behavior. Like bees or ants, these robots communicate and adapt, responding to their environment as a collective. Each RoboBee needs tiny sensors, miniature cameras, UV detectors, to spot flowers, just like real bees. These sensors help them see the world in ways humans can't, detecting patterns and colors invisible to us. The swarm maps the field, tags pollinated flowers, and spreads out for maximum coverage. Every RoboBee shares its findings, building a living digital map that guides the entire colony. GPS isn't accurate enough, so RoboBees use optical flow, analyzing how the world moves past their cameras to navigate. This lets them fly with precision, even in crowded, ever-changing environments. This decentralized bottom-up intelligence lets a swarm of simple robots do an incredibly complex job. Each one makes decisions locally, but together, they solve problems that would overwhelm a single machine. No single leader, just collective action. The swarm moves as one, guided by shared information and instinctive cooperation. But every drone must work almost perfectly. An immense engineering challenge. Even a small flaw can ripple through the system, so precision and reliability are crucial at every step. The hive mind is beautiful, but it's also fragile. A single disruption can threaten the entire colony, making resilience as important as intelligence. Building a mechanical colony is as hard as building a single bee. Each RoboBee is a marvel of engineering, and together, they represent the future of collective intelligence. Building a robotic bee is tough. So, what if we just borrow a real insect? Enter biohybrids. Researchers glue tiny sensor backpacks onto moths or beetles, using the insect's own flight and power. Some go further, implanting electrodes to control movement, turning bugs into remote, controlled drones. It's controversial. Are we making puppets of living creatures? For pollination, there's a gentler idea. Dr. Miyako's pollen-carrying soap bubbles. A drone releases pollen-infused bubbles over orchards. They land, pop, and pollinate. 95% success rate. It's low-tech, playful, and avoids ethical minefields. Sometimes the best solution isn't the most complicated, just a drone and a bubble gun. Cyborgs and bubbles. Two wild shortcuts to pollination. The future might be stranger and simpler than we think. Forget tiny robots. Israel's Egdet Precision Technologies built a tractor-sized pollinator. It harvests, stores and blasts pollen onto flowers using electrostatic charges, mimicking how real pollen sticks. AI-powered cameras target only flowers ready for pollination, making it smart and efficient. Unlike bees, it works rain or shine, day or night. No weather worries. It's industrial-scale pollination, not mimicking nature, but overpowering it. Already used on almonds, pistachios, apples, and cherries, it's a real-world solution for farmers. It's not elegant, but it's effective. For growers, a pollen-blasting tractor is a lifesaver. Sometimes brute force beats delicate mimicry. The future of pollination might be big, loud, and unstoppable. RoboBees sound like sci-fi, but there's a dark side. Think Black Mirror. Millions of autonomous drones are a security risk. Hackers could hijack swarms, disrupt food supplies, or worse. The military is interested, Tiny drones make perfect spies. Dual-use tech means pollinators could become surveillance tools or weapons. The line between agriculture and espionage is thin. We must build in security, encrypted controls, fail-safes, and robust protocols. One malicious use could destroy public trust forever. RoboBees must be safe, not just smart. The nightmare scenario, our ecological fix becomes a security crisis. Power is RoboBees' biggest problem. Batteries are too heavy, so why not use the sun? Researchers are developing flexible solar cells that act like a skin built into the wings. The wings become solar collectors. Bio-inspired, elegant, but limited by size. Solar RoboBees can only fly in short bursts, then must perch and recharge. Enter Perch-and-Stare. Fly, land, recharge, repeat, just like a real insect resting. Electroadhesion lets them stick to surfaces with a tiny electric charge, saving energy. It's a game changer. Finally, a path to true autonomy. Not perfect, no flying at night or on cloudy days, but a leap forward. Solar wings, smart perching, and sticky feet. The RoboBee is almost free. The power puzzle is closer to being solved. RoboBees are amazing, but there's a risk: complacency. If we rely on robots, will we stop fighting for real bees? Bees are keystone species, vital for wild plants, animals, and entire ecosystems. RoboBees can't replace that. They're for farms, not forests. And what about e-waste? Millions of dead drones could litter the environment. We don't know how flying robots will affect birds, bats, or other insects. Nature is complex. Introducing artificial pollinators is a gamble. RoboBees are a tool, not a replacement for nature. They're a desperate measure, not a solution. The real answer is to save the bees we still have. RoboBees are an engineering marvel and an ecological tragedy. They're a wheelchair for a broken planet, a backup plan we hope we never need. The real solution is to stop killing bees, change our practices, and heal the environment. Robots can't make honey or sustain wild ecosystems. They're a tool, not a replacement for nature's wonder. Let's fix the root problem, not just build better lifeboats. Thanks for watching. Buzz the subscribe button for more science dives.